Hello and good evening, CSI258 Section 847 students for the second 8-week term in the spring 2015 semester at Anne Arundel Community College. This evening's packet tracer tutorial is going to be one of my favorite. It's the Skills Integration Challenge for the end of Chapter 7, and this is packet tracer activity 7.5.1.2, where we now get to pull together all of the knowledge that we've gained so far, and we get to apply a lot of that knowledge into a complex packet tracer activity that's going to require us to perform a series of tasks. As you can see here in the Skills Integration Challenge, we've got our addressing table, and we're going to be referring to that as well as the DELC mappings, right, the data link connection identifiers. So the background is this is going to allow us to practice a variety of skills. We're going to get to work with frame relay, point-to-point protocol, challenge handshake authentication protocol, network address translation, overloading with PAT, and Gre Tunnels. The only thing missing here would be configuring the routing protocol and maybe slipping IPsec into our setup. So let's go ahead and take a look here. The only drawback here, it says you only have console access to router R1, and we have to telnet to the HQ router. So let's go ahead and knock out our console connection first. Alright, so we now have our console connection. Now, I've actually tried every possible setting to make that text right there larger than it shows on the screen here, and unfortunately that is as large as it will get. I cannot get it to size that out any larger. In fact, let me double check here. Let's make sure with our fonts I've got everything, tooltips, button menus, general interface. So yeah, I mean everything that could be increased has been increased, and there's really no other way to make that any larger. So I'm going to go ahead and make sure that I spell out exactly what I'm doing. So let's go ahead and stretch this out here. So this is the only way that we can attach to router 1 is through the console port. So from user exec mode, we're going to issue the enable command. To get to privilege exec, I'm going to say conf t to get to global config. And so the first thing we're going to do here on router 1 is we're going to configure full mesh frame relay. Now remember, with full mesh frame relay, we're going to have a single IP subnet here, right? So this is going to be .3, 10.0.0.3, HQ is .1, and I'm just looking at the addressing table. And router 2 is, as you would expect, going to be .2 inside our frame relay full mesh configuration. All right, so let's go ahead now and jump into, on router 1, we're going to go in interface serial 000. And how do we enable frame relay as our encapsulation? We simply say encap, and you should be familiar with this, HDLC, PPP, and frame relay. So I'm going to say encapsulation frame relay to change the encapsulation on router 1 to frame relay. And now we're going to have to configure a map to each of the other routers leveraging the broadcast keyword. Now remember, this is not point-to-point frame relay. If it was point-to-point frame relay, that would solve the issue of having to use the broadcast keyword. But by default, in a full mesh, it is a non-broadcast multi-access topology, right? So we have to facilitate the capability of being able to send broadcast traffic, and in doing so, that also includes multicast traffic, which is going to allow our routing protocols to establish their adjacencies with neighbors. So let's go ahead and get our maps ready. So I'm going to say frame relay map IP, and now it says protocol specific address. So for IP, let's start with router 2. So I'll say 10.0.0.2, and now I have to enter the DELC. And if I refer to the table here, I'm on router 1. My DELC for router 2 should be 302. So I'll put in 302 with a question mark, and there's our broadcast keyword. So we'll get the broadcast keyword in here, and we'll see if this brings up any kind of an EIGRP adjacency. Excuse me, EIGRP adjacency when we get done and get the configuration in here for the HQ router. All right, so now let's go ahead and add in our next statement. So frame relay map IP 10.0.0.1, and from router 1's perspective, we're going to be using the DELC of 301. So again, what we're saying with that frame relay statement is my frame relay map to get to IP 10.0.0.1 is going to use DELC 301. And so it's going to go out the serial 000 interface into the frame relay cloud, where it will then be switched via the frame relay switches, which can be Cisco routers, and it will be switched upon DELC value 301. All right. Let's see here, and we need the broadcast keyword, so we'll get the broadcast keyword in there as well. And then we're going to do the frame relay local management interface type, and wants it to be set to ANSI. Is that correct? Yep, LMI type of ANSI. All right, so we've completed our configuration on the frame relay, and there we go. So take a look there. We now have our adjacency is up with router 1 as well as router 2. So if I were to say do show IP EIGRP neighbors, you can see that I've got adjacencies with router 1 and router 2. How about a do show IP route? And I am learning the 10.1.100/24, which is the subnet behind router 2. I am learning that via EIGRP. There's my administrative distance, right? And there's my metric to reach that route, and it's via 10.0.0.2. And so if I were to say do show run, we can see that the routing protocol is running, and here is our setup on router 1. And we've got the very popular passive interface command on the gig 00 interface here towards our LAN segment, because we don't have any EIGRP speakers. And then we're actually just activating it on network 10.0.0.0. Now, what version? Do show version. So we're running version 15.1. How will we check to see if we have auto summary enabled? So I'll say do show IP protocols, and automatic summarization is disabled, right? And again, definitely something to check in the early 15.x code trains to confirm. But if you're running any ISR G2s today, you should be using the MD release right around 15.4.3 is where you should be. And from what I've seen, the behavior is that it is disabled by default, and it should be. All right, so I'm going to say end on router 1 here, and we're going to say write mem. We're going to save off the configuration. Oh, I'm sorry. We'll save the configuration. Let's go ahead and add those GRE tunnels in to each of the other routers. And so the GRE tunnels are very straightforward, especially if you think of them in the context of it's just another virtual interface, just like a loopback address or an SVI. So I'm going to say int tunnel 0, and just like the SVI or the loopback, we're going to say IP address 192.168, and if I refer to the routing table there for tunnel 0, it's going to be .1.6, and that is a /30. So we have our IP address. Now, what are the two things I need to tell the tunnel? Well, what's your source? And it's going to be that outside facing interface, that serial 000 interface. And then where am I going? What's my destination? Well, my destination for the 192.168.1.6 is going to be the tunnel 1 interface. I'm sorry, is actually going to be the frame relay interface, the serial 000 interface over on router, the HQ router, and that is going to be 10.0.0.1. And I always like to get in the habit, tunnel mode GRE IP, right? Okay, so that takes care of tunnel 0. Now let's go ahead and do interface tunnel 1. And again, IP address for tunnel 1 is 192.168.1.9, and this is a /30. Because remember, the GRE tunnel interfaces, think of them as being synonymous with your point-to-point dedicated circuits, right? So you've got two serial interfaces with a dedicated circuit in between them, and it's a point-to-point configuration. And really, that's all we're doing, and we're just simply replacing that dedicated point-to-point circuit with the tunnel interface. So we say IP address 192.168.1.9, and it's a /30, and then what's my source? So my tunnel source is still going to be serial 000. My tunnel destination is going to be the frame relay IP of router 2, and that's going to be 10.0.0.2, and then we'll say tunnel mode GRE IP. All right, so now that takes care of the configuration for router 1. All right, now, and this is a small annoyance here, but not that big of a deal. So now how do we get over to the HQ router? Well, the only way to get there is to telnet. So I'm going to say telnet 10.0.0.1. So we've got a username of admin and a password of admin pass. All right, and now we are in the HQ router. All right, so we're going to configure the HQ router to use PPP with Chap on the link to the internet. So let's go into interface serial 001. We're going to say in cap PPP, right? Just like we did with frame relay. However, here we're using PPP. Now we're using authentication as well. So the book shows it with authentication configured going both ways. Again, there's nothing wrong with that. There are use cases for it. However, the typical sort of classic use case / deployment model is that it is the provider, right, the ISP, the service provider, who would have the PPP authentication Chap configured on their side, because that's what initiates the Chap challenge, right? So typically, it's not the customer challenging the service provider. It's typically the service provider challenging the customer. And let's see here if we go from 48 to 49 points. Actually, it goes to 50. So that was 2 points to configure it just like that. And again, I didn't know it needed to be done like that, but the book has shown it like that several times, and I think a number of the other packet tracer activities have also shown it where you've got mutual Chap challenging, right? So mutual authentication taking place. And again, nothing wrong with that. You can certainly set it up like that. So we've got in-cap PPP. We've got our auth sent to Chap. Let me back out here, and we're going to say username. The username is going to be ISP, and the password is going to be Cisco. And let's see if it wanted the secret. Nope, it just wants the type 7. So we're good there. All right, so configure the HQ router to use PPP with Chap on the link to the internet. ISP is the router host name. The password is Cisco. We've got that. Now we're going to configure GRE tunnels to the other routers. So again, very straightforward. So I'm going to say interface tunnel 0 and IP address. And let me scroll up just a skosh there. All right, IP address is going to be 192.168.1.1. This is /30. And so then what is my source? Well, it's going to be my serial 000 interface, and my destination. So 192.168.1.1 is going to be in the same subnet as the router 2 tunnel 0 interface. So I want to use the outside address, right? Not the tunnel address, but the outside address that I'm routing to get to router 2, and that's going to be that frame relay address 10.0.0.2, and then tunnel mode GRE IP. So that takes care of our tunnel 0 configuration, and let's go ahead and jump in to tunnel 1, where we're going to say IP address 192.168.1.5, and this is a /30 as well. And the tunnel 1 interface partner is the tunnel 0 interface over on router 1. So my source is going to be serial 000. My destination is going to be the frame relay IP of router 1, which in this case is 10.0.0.3. We'll set our tunnel mode GRE IP. So that takes care of our configuration there. And let's take a look here. Again, very short skills integration challenge, but some very good steps in here that we need to get down. Let's see, configure the tunnel interfaces. We did that. So it looks like we're at the NAT configuration here on the HQ router. So it wants NAT to share the public IP address configured on int serial 001 with the entire Class A private range. So basically, anybody coming out of the frame relay cloud is going to be able to get out to the internet and therefore the web server. So the first thing we want to do is our access list, right? So access list 1 permit, well, which range are we allowing? It just told us the entire Class A range. So permit 10.0.0.0 and the wildcard mask is going to be 0.255.255.255. So we've got our ACL configured. Now let's go ahead and set our statement. So IP NAT inside source list, and remember the list is going to refer to the ACL. So 1, and what are we doing? Is it a pool or an interface? Well, we're going to use the interface serial 001. And remember, you can use the interface, right? And we're basically doing NAT overload, which is also known as PAT, or port address translation. All right, so on the HQ router, we've got that set up. The last thing to do here is to go into the serial 000 interface, and this is our IP NAT inside, and we want to go to the outside interface, where the inside global address is going to be found, and we're going to say IP NAT outside. So we've got our IP NAT inside and our IP NAT outside statements. We've got the serial interfaces configured. Let's go ahead and say end, and I'm going to save my config. And let's pull up PC2. It says here, what are we looking at? The end devices should now be able to ping each other and the web server. So let's pull up PC2 and see what kind of connectivity we're looking at right now. So I'm going to say ping 209.165.200.226, and this is definitely going to probably miss a ping or two because it's going to have to ARP out for its default gateway, and there we go. All right, so the ping connectivity works. Can I ping PC1? So let's give that a try. 10.1.100.10. Actually, that's me. And let me switch this here to 150. All right, so now we're going to try to ping across the frame relay cloud. So our first request timed out, and then we've got connectivity. Let's take a look here and let's see how. Oh, sorry, trace RT. So we'll say trace route, and let's trace route over to 10.1.150.10. And what path are we taking? Well, our first hop is going to be the first hop is going to go to the default gateway, right? Router 2. Router 2 is going to take that and send it to 10.0.0.3. And so what do you notice there? Did it take the tunnel? It didn't take the tunnel, right? And then we've got 10.1.150.10. So we'll take a look at why it's not taking the tunnel here in just a second. So then it makes it to its destination. So let's go ahead and pull up PC1, and I'm going to have to close that down. So I did save the config. So and actually I can't look at router 2. So if I were to say show run, let's take a look. Our tunnel interfaces are 192.168.1s. However, we set these tunnels up, but what is EIGRP routing by? Well, EIGRP is routing by the 10 dot, right? So it's using the network statement. So that's the network that EIGRP is advertising. And if I were to say show IP route, you can see that we're only picking up the locally connected. And in fact, take a look at this. EIGRP is advertising a default route. This is being done off the HQ router. So a static default route has been configured on the HQ router. and we are redistributing static in the EIGRP process. So we're not actually configured to use the tunnel, right? So hopefully you see that. So we're not actually configured right now to use the tunnel address or the tunnel transport. We're only set up to go over the frame relay cloud, right? So that's why we're not going out the frame relay cloud. So let me get the command prompt up. Let's ping 209.165.200.226. All right, so we can ping the web server, and since PC2 could ping us, we should be able to ping PC2 without any problems at all. So again, a good activity. It would have been nice to have allowed us to create the routing protocol and to also pull in the information that we would have add in the information that we would have needed in order to route over the tunnels, right? To use those tunnels. So we set the tunnels up, but we weren't really using them. And if I were to pull, sorry about that, pull PC1 back up here and say trace route to 209.165.200.226, you can see that again we're not using the tunnel because there are no routes on any of the routers that I'm aware of for the 192.168.1 subnets that we are using for our GRE tunnels. And again, since we have the broadcast statement with the frame relay config, we really don't need the GRE tunnels. However, it had us set them up anyway. So, all right, again, very quick skills integration challenge this week. Not too in-depth, but I like it because it really pulls together a number of individual components that we've been working on and blends them together so that we have an opportunity to apply all of the knowledge that we've picked up as we've been going through the course. All right, well, this completes Packet Tracer Activity 7.5.1.2, the Skills Integration Challenge for Chapter 7. Thanks for watching, and I'll see you on Saturday.